All right, cheers. Then for the next 15 minutes, let's boldly go where no cloud engineer has gone before. I will be talking about clean and secure infrastructure as code. It's a talk that is kind of highly inspired by my project work, by my consultancy work I usually do in my day-to-day job. And it's inspired by, well, my lecturing, part-time lecturing job in software quality assurance here in my hometown. So that you all know where I'm currently broadcasting from. So this is south of Germany. This is Bavaria. My hometown, Rosenheim. Austrian border is 30 kilometers that way. The mountains are already white. Winter season will start. If you're interested in the slides, I will post them on Speaker Deck just after the talk. If you're interested in the code I'm going to show you or the demos I'm going to show you at the end of the session, then head over to my GitHub account and fork the repo and use it however you prefer. Excellent. So let's dive in. When I think about, I personally as a software engineer, a software architect, when I think about building a systems and I think about the fields of clean code and clean architecture and maybe quality assurance and also security, then I usually do that on three levels. I do that on a conceptual level, on a technical level, and also on an infrastructure level. So on the conceptual level, you usually talk about data models and use cases and functional requirements, and you think about how maybe to secure them also. And possible outputs here are kind of the domain concepts, domain interfaces, and the system context your system will integrate into. On the technical level, this is kind of where most software engineers are about, where you're actually building software, right? You talk about layers and onions and hexagonal architecture. You're kind of choosing the right open source components you want to use. Maybe in the Java world, you're using the Spring framework or any other, fancy library out there. And on the infrastructure level, obviously, this is what it's going to be about today. Well, you may have to adhere to some enterprise standards or to some corporate infrastructure. You talk about which type of hardware do I need? Do I need compute, network, storage, operating systems, application servers, databases, your ops components, right? Your Docker containers or whatever which technology you're using. And if you want to secure that one, well, holistic security needs to be applied to all those three layers, right? For today, we're only going to focus on the infrastructure level, okay? Because this topic here, how to, craft the proper security architecture, is a talk on its own for, I don't know, at least 2 hours. So let's focus on the infrastructure. Now, I think the big challenge most teams nowadays are really faced with is that the infrastructure level, it changed. It changed drastically, right? Maybe you come from on-premise, centrally managed infrastructure, and now the DevOps teams out there, they're kind of overloaded with, you need to containerize your stuff, and you need to run it on Kubernetes, and obviously you have some public cloud provider you want to use. So the technologies and frameworks and also the responsibilities, that changed a lot. And I think this is kind of part of the problem why there is so much possibly badly crafted, infrastructure code out there. If you have a quick look at that one here, that's an ISO norm, okay? And it's the ISO norm on good software product quality 25010, right? And in the upper right corner, you see this good old maintainability. This is usually what clean code is all about. You talk about modularity, reusability. It needs to be testable and modifiable. But also you have security as one of those key entities also, and maybe reliable. And my claim is that the architecture and also your infrastructure code plays a crucial role in addressing those the maintainability, the security, and the reliability also on an infrastructure level, right? And you need to have maintainable code in the first place to then enable, to be able to make it secure. So if that is so clear that we need secure, reliable, maintainable infrastructure, then, this is my experience, what the reality looks like, yeah? It's not only a few broken windows, it's sometimes a mess. It's huge, humongous Terraform modules that are highly tangled, that are badly crafted, a lot of repetitions, a lot of redundant code out there, especially in the Kubernetes YAML world. So why is that? Why don't we treat our infrastructure code as a first-class citizen? Why is it just a side product, a byproduct we just happen to need because we're in the public cloud now, right? And that one here is also very true. I know I'm exaggerating a bit, but this trial and error thing seems to be the predominant approach when you try to get your infrastructure code up and running, right? No matter if you talk about your Docker file or your Kubernetes manifests or your Terraform definitions, it's usually like, okay, well, I Terraform apply and plan apply as long as it starts to run. And once it's running, yeah, git commit push, done, all done, things work. Maybe you open the AWS console and you check, is my infrastructure up and running, right? Why is that the predominant approach out there? Why don't we apply good old test-driven development, for example, right? And my claim is infrastructure as code without tests is broken by default, right? It might work at the first commit, but once you start to, to evolve your system, once you start to make changes, right, then the drift stuff really starts to happen. We just heard about before, and that is really dangerous, right? I mean, that is dangerous from a security point of view as well as from a maintainability point of view. So you might have seen my title screen, right? And I kind of, took the picture of those two well-known books, at least in the software engineering community, and I'm pretty sure you've heard of those or maybe read those. So many of the principles on clean code and clean architecture that Robert C. Martin talked about in those books, right? They should apply and they must be applied to your architecture or infrastructure code also, right? To make it maintainable and to make it secure. So let's have a quick look how that can be done. Well, first stuff, KISS, keep it simple, stupid, right? Don't make it overly complex, right? Well, at least not at the beginning. It will get complex over time, of course, but start off small, start simple, reduce complexity, apply emergent design, apply evolutionary architecture, that kind of new thought from ThoughtWorks proposed for standard code, right? Apply those practices as well. Separation of concerns. Also, think about modules, think about layers, think about components. Your components, infrastructure or infrastructure code components, they should be loosely coupled. They should have high cohesion, right? With this separation of concerns, you can have a big platform team working on the same code base without breaking each other, right? And this is a kind of a guarantee and a must for maintainable infrastructure code. Don't repeat yourself. I've seen so many Kubernetes manifests that were highly redundant because they're kind of copy pasted over the different environments. Like you have the int environment and a QA environment and maybe a pre-prod and prod. And what did the folks do? They just copy pasted it into different folders, right? So guess what? If you have to make a change or you fix a security leak, then you need to remember, oh, I have to do it in 4 different places, right? So get the redundancy out of your code. Another one, solid, maybe not so relevant in an infrastructure world, but I think single responsibility principle also highly relevant, especially in a Terraform world. If you're designing Terraform module, a module should have a single responsibility. And also the interface segregation principle, right? Don't write Terraform modules that have 75 input variables and 35 output variables. You would never do that in an application code level world, writing an interface with an apply method that takes 75 input parameters. Who on earth would do that, right? So don't do it in an infrastructure world. This here is clean code in a nutshell on one slide. Have a look at that one link down there. It's a really useful summary and a good overall overview. Follow standard conventions. Good naming, obviously. Yes, don't state the obvious in your comments, but maybe clarify your code or put warnings in form of comments. Prevent over or configurability, right? Don't do that. Prefer data structures. Keep your source code clean. Format it. Be consistent. And yes, write tests also in an infrastructure world, right? So have a look at those clean code principles and do some thinking and apply it to your infrastructure code. Before you start to write any code, maybe it's about time to think about the conceptual architecture of the infrastructure you're planning to build, right? Because this will have a significant impact on the source code structure and also on the kind of security measures you may need to address within your conceptual and then technical IT infrastructure. Which regions do you need to run in? What do I need to replicate? How do I model environments? Do I use VPCs? Do I use accounts? Do I use Kubernetes namespaces? I don't know, but choose, right? And make the thoughts. Which network level access controls are required, right? How do you need to separate maybe your subnets or whatever? Think about those layers, think about those components, and think about the dependencies between each other. How is the data flow intended to be, right? And then in the end, you can then decide, okay, and how do I structure my stuff in Git repositories and the source code using folders, for example. Also this one here, I know cloud native world is great, the landscape, we love it, right? And it's so easy to pick so many tools. My big advice is decide early as a team on the technologies, on the tools, and on the frameworks you intend to use. And seriously, think about KISS, right? Keep it simple, stupid. Less is more, because the more you have to think about clean code, and the more you have to think about security, for example. So rather reduce your technology footprint, reduce the amount of tools you're going to use and the amount of frameworks you're going to use, and it will be a lot simpler, by your teams or by you to get, to craft clean code and to craft clean and secure code, right? Excellent. So 4 minutes left. I hope I made my case. Let's jump into some tools I found very useful, or we're using in our projects quite often. So as I said before, demos and examples. Here's the URL. Clone the repo, MIT license, free to use. Pick what you like and apply to your project. So let's have a quick look. Wow, Docker world, right? We all love Docker. Now, the good thing is, with most of the approaches I'm going to show you, what is an established practice in software engineering? Well, you use static code analysis, for example. Well, use a linter, right? Lint your Docker files to find out those, if it adheres to some certain best practices. So you can codify with, for example, this tool Dockerfile lint here. You can codify. I'm in the wrong directory here. Let us see. Right, you could codify your rules you expect your Docker file to adhere to, and it will then tell you, well, listen, the labels are not good, and maybe you should use a user directive and the expose directive, so whatever. So put that onto your developer machine, put it onto your CI system, and then regularly check your stuff, right? This is super easy. This is not hard, right? Maybe do some security checking on the Docker file you just did, right? I mean, of course, this is a Hello World demo example here, but let's wait a bit. And what's the output, right? I mean, seriously, would you want to ship an image to production with 110 issues? Well, I hope not, right? So do your homework. Maybe use a tool like Container Structure Test. Check your images, right? Does the image content adhere to my expectations, right? Are the files in there? Are the permissions set correctly? Does it start? Is the path set correctly? So different things you can do to check your stuff, right? So here I have 6 passes. So it's not that hard to implement proper testing. And if you're in the Go world, well, there's a pretty cool framework out there. It's called TerraTest. And from the name, you can already expect where it came from or comes from. But you can now codify in a Golang test, for example, to, well, regularly, as a kind of integration test, build the image, execute a run command, and then do some sanity checking on your image. Same is true in a Kubernetes world. And possible in a Kubernetes world, right? Kubeval or kubescore you can use to kind of, give you an impression how good is my deployment manifest, for example. And there are certain best practices you should adhere to, right? And you see here, well, image pool policy is not the correct one. Container resources is wrong. I have no network policy defined. The security context is wrong, and so on and so forth. Polaris, Snike, you can use as well. If you like, you can use Chekhov's. There are so many good tools out there that help you in write clean and secure, well-crafted, Kubernetes manifests, for example. And finally, to get rid of this usually highly redundant boilerplate stuff in this YAML hell world, well, maybe you should use Customize, or maybe use Helm to get rid of those redundancies between those environments in the Kubernetes world. And last but not least, guess what? Well, TerraTest can help you to kind of integration test your Kubernetes YAML. We have the infrastructure in a cloud world. We have the cluster running in most cases. Why not use it for good reason and for good purpose, and to make proper integration tests? Right? And last but not least, good old Terraform. Guess what? Same here, right? You can use TF-Lint. You can use for the public cloud provider specific rule sets to find those errors in your Terraform code that the good old Terraform plan does not find, right? Use Checkov, use Snike to find those security, and also use TerraTest to finally integration test your modules. All right? And maybe last but not least, have a look at TerraGrunt as a kind of a dependency injection frameworks to kind of wire up all your modules with each other, to wire the outputs of one Terraform module into the inputs of another Terraform module. So do you know this? It only requires a few tools. This is all you have to do. Put it on your machine, put it on your CI server, and you're done. You're able to craft clean code, and you're able to craft clean and secure infrastructure code. All right, that was it.
Wow, thank you so much, Mario. Really great examples there. It was nice to see.
Yeah, the actionable code examples, I think they're very, very great and actionable things that people can definitely use. I love how you state that the basic principles of software architecture and clean code, what we use as a developer, actually also apply to your infrastructure as code. And that is just, essentially, it's more of the same, but you just need to apply it.
Yes, exactly.
So if I recall correctly, do you advise to minimize your infrastructure stack as much as possible to keep it simple?
I would advise at least to start off that way, because well, on the one hand, you have this clean code and security aspect, and on the other hand, you have the cognitive load aspect on your teams. And what I see out there is, usually young teams starting off fresh. They're highly energetic. They use every tool they can, but in the end, it's to their disadvantage, because you have to master those tools. You have to master the technologies, and this brings complexity. And with the complexity, then comes cognitive overload, and then the things start to break, and then things start to to be not that clean and not that secure anymore. So start off with a sane small default, and then you can evolve. Okay.
Absolutely. I also think it's a very good thing if you keep it simple, as not too many techniques or too many different parts in your stack. It's easy to transfer if a new team member comes in. So the cognitive load is not that hard, and the onboarding will be easier. So absolutely, totally agree with you.
Right, and you would do the same as normal software engineering, right? Yeah. It's not a good idea to have like the whole half internet as as library dependencies in your Maven POM. No normal software engineer would do that, or hopefully not, right?
Hopefully not.
Fingers crossed.
I think that is the correct wording. Mario, thanks again. I love the actionable code examples. So if you want to try that out yourself, please go to the GitHub repository and try it out. If you have more questions for Mario or questions about the code, of course, you can ping him either on Hopin or the Slack, or you have his GitHub account. So ask a question there if any specific things don't work or don't work in your situation. Feel free
Feel free to contact me.
Yeah, absolutely. Thank you again, Mario. And
right.
I hope you enjoy the rest of the day, because we have more up and coming.
Yeah, cheers. I definitely will.